Hello and welcome to another tutorial. We are looking at the Java language basics, and so far we've looked at many different things, and now we're looking at the control flow statements. This section describes the decision making statements, and you already know that it's going to be if-else statements. We have switch statements, which is the topic of the next sections. The looping statements, while loop, if loop, do while loop, and the branching statements supported by Java language programming. So let's dive in. Control flow statements, the if then, basically if statements, if else, while and do while loops, for statement, break statements, continue statements. Break and continue are basically conditionally skipping a loop or breaking through a loop. So these two are not, these are for controlling the loop, but these don't create loops. They just break either out of the loop or skip over some parts of the loop. Return statement, you've seen it before. It's just a method. Anything that you can do some calculations in the JVM, it puts the results on the stack, and eventually you can return the final result from a method or something that is callable, right? Anything that you can call, you can return something from it. And the yield statement, and yield is actually pretty new. I believe they added it in JDK 15, and it's good to also look at it here. So let's start with the old school if statement. The if then statement is the most basic of all the control flow statements, right? So if means you give it a condition. So if, and then it takes around a pair of round brackets. Inside of that, you give it a condition. The expression that you put in the argument of if has to be evaluated to a Boolean type, right? Otherwise, Java doesn't allow you. In C++, it's not the case. In C++, if you, the condition of the if has to only evaluate to something which is 0 or non-zero, because in C++, anything that is non-zero is true, is considered true. But in Java, the argument has to evaluate to a Boolean type. Otherwise, the Java compiler doesn't compile your code. So and then we said that the way this works is that the condition in the bytecode, and we will look at this in the bytecode, the value of the Boolean is just integer, 0 and non-zero. Let's say 0 and 1. And so the bytecode is just if equal or if not equal 0. So in the bytecode, the JVM looks at the value of the Boolean type of the condition, compares it with 0. If it's equal to 0 means the condition is false. If it's not equal to 0, it means the condition is true. So the if statement tells your program to execute a certain section of code only if a particular test evaluates to true. For example, the bicycle class could allow the brakes to decrease the bicycle's speed only if the bicycle is already in motion. And one thing that I want to mention is that try not to do calculations in the expression of the if statement. Instead of, if it's a static value, it doesn't change as the condition, or if you put it in a loop. Try to cache that value and put that cache value in the argument of the if statement, so that you don't reevaluate the same expression over and over again. This is just some optimization tactic. One possible implementation of the apply breaks method could be as follows. So we have a method, and again, the method is you declare the return type. In this case, void means it doesn't return anything, and then the name of the method. And then it could be also, it could have access modifiers like public, or access modifiers go before the return type, like public, private, protected. And then it could be either a class method or basically a non-static method, which means either it's a static method or non-static. And then you name of the method, a pair of round brackets, and then inside that you declare the parameters, right? And again, I mentioned this before, parameters of a method are defined, or basically are considered as local variables. So the if clause, bicycle must be moved. So if we write the if, we use a pair of round brackets, which is mandatory. In programming languages such as Python, this pair of round brackets is not mandatory. But then you have to terminate with the colon. In Java, you don't use any colon. You can create a scope, but that's not mandatory. If you don't create a scope, only the first line after the if condition is considered part of the if. So if you have multiple lines as part of the if statement, you have to use a scope. Otherwise, only the first line is considered, right? So this is a mistake that usually inexperienced programmers encounter, right? So make sure that the best practice always create the scope. You can program your IDE code formatter to automatically generate scopes for any if statement you write, and that makes life easier if you want to stick with the best practice of always creating a scope for the if statement, even if you have only one line of condition or one line of code in the if the body of the if statement. So we just say that if is moving. Remember, is moving right now, it's not an expression, right? So the compiler or JVM doesn't have to evaluate this variable is moving, because it's not an expression, it's just a value, it's a variable and has a already evaluated value. So we just and it has to be of type boolean. That's the restriction that Java enforces. This variable that goes in the condition or argument of the if statement has to be boolean. So if this basically evaluates to true, the condition is true, then we execute the body of the if statement. And again, the body of the if statement is all the lines of code that are encapsulated in the scope of the if statement. And again, just like any other scope, this is a code scope, which means you can declare local variables inside in, and those local variables are not accessible outside the scope of the body of the if. You cannot define any variables in the arguments of the if. You can just put a condition. The only thing that you can do in the argument is to put an expression that evaluates to true or false, right? That's the only thing that you can do. You cannot declare a variable in this part, right? So if this test evaluates to false, test means the condition, meaning that the bicycle is not in motion. Control jumps to the end of the if. So if this evaluates to false, we don't execute the body, we jump over it, and then we go to execute whatever is after the if statement. In addition, the opening and closing braces are optional, provided that the then clause contains only one statement. So what this means is that if you only have one statement, when the condition is true, basically the body of the if statement only has one line of code, or one statement. Remember, a statement is anything that terminates with semicolon, and I said that we can put multiple statements on the same line, but if you do that, only the first statement is going to be considered part of the if statement. So again, be very careful. It doesn't mean the first line after the if is going to be part of the if. Only the first statement after the if is going to part of the if. And the reason is that we can have multiple statements on the same line, but only the first statement is considered part of the if. So again, the best practice, always add a scope to your if, the body of your if statement, to make it very clear that what's going to be included as part of the if statement. Deciding when to omit the braces is a matter of personal taste. You can also set up your IDE, the code formatter, or the auto formatting of your IDE, to always add these braces when you hit the Command-Shift-F or run the auto formatting. Omitting them can make the code more brittle if a second statement is later added, which means now let's say you write this code, later on you decide to also add something else. When this F clause is true, then if you put another statement below this line, it's not going to be considered part of the if, unless you put a pair of braces so that you explicitly tell the compiler these two lines or these two statements are part of the if clause. A common mistake would be forgetting to add the newly required braces. The compiler cannot catch this sort of error. You will just get the wrong results, right? So let's create a package here, conditional, and we're going to create a class if clause or if statement. Let's have a main method here, and in the main method, right now my code formatter is formatting, so let's go back and change the code formatter to the default Eclipse. I'm going to press Command-Shift-F, and now this is the default Java style. We put the opening brace on the same line. So I'm going to declare a static method, public static void test1. We're not taking any arguments, and here we're going to invoke test1. So what's the goal here? We want to see how the if statement translates into the bytecode, and then we're going to also look at some of the pitfalls of not declaring an explicit scope. Alright, so if a statement in the bytecode. So we're going to say that Boolean condition is true, okay? Or let's say make something that we can evaluate, 5 greater than 3. These are integer literals, and we already have seen in the previous lectures that this will not be evaluated at runtime. At least Java compiler is not dumb enough to just defer this to runtime. So Java C, although it's a dumb compiler, can evaluate all the literal expressions at compile time, which means that if you look at the bytecode, most likely we're going to see that this condition, when it's written, the bytecode is written, this condition is always true or false, right? No expression. This will not be evaluated in the bytecode. The Java compiler evaluates it and decide whether it's true or false, because this is an expression that mainly formed of literals. So there is no reason for Java compiler not to be able to evaluate it. It has to be. That's the job of the compiler. Obviously, Java C is a dumb compiler, so it cannot do much. They deliberately handicap Java C so that at runtime the JIT compiler has more things to work with, right? All right, so and then we say if condition, we're going to do a sysout statement 1. And the reason I'm going to add more lines, and we see that how what the problem is with not having the explicit scope. So here at the moment, I'm going to write it no explicit scope for if statement, right? So there is no, we didn't create a pair of curly braces. A scope means a pair of curly braces, but we didn't write it. And note that we can even write this on the same line, because the entire if condition and the line that comes after that, this is the entire thing is one statement. So it's not like if is one statement and then the line after that is another statement. The reason is that, again, the definition of a statement, anything that is terminated with semicolon, and this is even valid, then this if condition becomes one statement, this becomes another statement, and these are not related. But if I remove this semicolon, now this entire if condition and this print line, these are all one statement. So entire if plus condition plus next line is one statement, because that's where you actually terminate with semicolon, right? You start from the last statement, the end of last statement, and then you move forward until you hit the next semicolon. That defines the statement, right? So this entire thing, obviously for more code readability, we usually put this on the next line, and the IDE is smart enough to realize that this is part of the if, so it automatically indents it. So IDE is smart enough to realize that. That's why you see this indentation happens, because IDE knows that this is actually part of the if, and it's for code readability, it's better to indent this, right? Just wanted you to understand this. So if I run this, obviously we see that this line is printed, which means the condition was true. Let's look at the bytecode. All right, conditionals. Let's open with the class file viewer, and let's look at what happens for the if statements in the bytecode. All right, so test 1. As I mentioned, we definitely expect to see that this condition is hard coded as true or false. And as you can see, the first line of code is iconst 1, load iconst 1, which means load true. So iconst, again, Boolean in bytecode means integer true. So load the value true, and when we const it, assign it to the store it in the integer variable condition. What this means is that in the bytecode, this was already evaluated by Java compiler, and the result was true. So instead of deferring this to runtime and asking the JVM to evaluate this, it just says, okay, this condition should be true, so let's load true. True means integer 1, a 32-bit value 1, and we load it into the stack and push it to this variable 1. We load this constant and then push it to the first index in the stack, which is the condition of a variable type integer. So integer, store an integer at index 0 on the stack. Why index 0, not index 1? I've said it many times, because it's a static method, so this pointer is not pushed to the stack of this method, right? Because it's a static method, so we don't push this pointer to the stack, right? Now if this was a non-static method, then we had to push it to the stack. So the first index for storing this integer would have been basically index 1. I can show you. So if I comment this out and then remove this static and save, Eclipse quickly compiles this, and now you see, now we get I store 1 instead of I store 0, which means now we're storing this variable in the index 1, which is the second place on the stack. Stack starts from index 1, not 0. Why? Because now this is a non-static method. So index 0 of the stack stores a pointer, a variable that points to this, right? It's the value of this pointer that points to the object itself. But as soon as I declare this as a static, then we don't deal with this pointer. So so save again, Eclipse compiles, and now we restore in the index 0. So these 2 lines of bytecode tells that the condition should be true always. So no evaluation for this literal expression. And then let's look at the if statement. We said that the condition has to evaluate to Boolean value, and then the way this works is that it just compares the Boolean value with 0, right? If equal means compare the last value on the stack, which is this condition value. If equal means if it's equal to 0, right? So if condition equals 0, this is a bytecode operation. Jump to 14. What is 14? Just return, right? So if equal 14, we jump to 14, which is the return. Why? Because we don't go into the body of the if statement, and after that we don't have any other line of code, any other statement, so we just return from the method. And this method returns void, which means we're not returning anything. So this is when the condition is not true, right? If equals 0 means the condition is false. Now what happens if the condition is true? Obviously we go and get the basically, let me zoom out, or maybe let's get this line by line. All right, so we go and get this a static field, which is the out. This is a print stream static field. All right, out. And then we go and load a constant. What is that constant? It's a string literal. Remember, string literals are stored as constant values in the string pool. So this is a constant, load constant, of type a string, statement 1. So this is a special value that loads a constant from the string pool. And then we're going to invoke the virtual method. Virtual means a non-static method, right? All methods, all non-static methods in Java are virtual by default. And that's the basically print line, right? That takes a Java lang string and returns void, right? So this is a body when the if equal to 0, which means the condition is false, is not satisfied, which means the condition is true, right? Now the question is, this condition is always true, but then why is it that we still have this jump? Because if the compiler could deduce that this condition literal, this expression was always true and the condition of true, why is it that it couldn't deduce that this if statement is redundant? Because this condition right now it's always true, then this if statement should always be true. So in the bytecode we didn't need to have this if equation, because we already know that the only path to take is invoke this, right? Why? Again, I mentioned this in many times, because this condition was not declared as final. As soon as I declare it in final, the optimization kicks in, and you see there is no if equality, there is no condition checking, because the compiler recognized that yes, the value of this condition is true, but there is no guarantee that it's not going to change because it's not final. But as soon as we give the compiler the guarantee that this is going to be final, then the compiler says, okay, now I know that from this line, from this statement to this statement, nothing changed. The condition, the value of the condition could not be changed, and I already knew that it's going to be true. So therefore it has to be true here. So there is no point to have a check for the condition because it's already true. So this is some sort of optimization. Again, any variable that you calculate and you know that you're not going to change it, any local variable, that you know that you're not going to change it for the rest of the method, but it's better to have it instead of just typing this expression over and over again. Definitely declare it as final, because then if you put it in the if conditions or do some other calculations with it, then you know that the compiler can optimize this, and that's a very good practice, right? That's one of the best optimization practices. So some people say that all the local variables should be declared as final unless otherwise necessary. So you can also stick to that rule, right? So this was the introduction to the if statement, and I hope you enjoyed this. In the future lecture, we're going to look more into what happens in the bytecode when we add more complexity to the if statement. We will also look at other type of conditionals like the loops. So please stay tuned, and I'll see you in the next one.